FIO Helper Class. You've already built the library class UI to aid with keyboard input. Now we're going to develop an FIO class, short for File Input Output. This class will help us in particular with the input and output in the MoniDevelop system. It also will illustrate a number of more generally useful ideas. You saw in the last section how numbers.txt gets accessed differently depending on different execution environments. Our particular situation is based on the particular choices made by the creators of MoniDevelop. But more generally than here, we're going to have times when a program needs to find a file that may be stored in one of several directories. And our class will address this. And we'll set it up specifically to deal with the MoniDevelop environment as we do it. We use one idea that's a little ahead of ourselves that's discussed more in the next chapter. We need a sequence of directory path strings to look through to find the right one. At this point, the only sequences we have discussed have been sequences of individual characters. Remember, we used a for each loop, for instance, to go through the individual characters of a string. We're going to have a variable paths that contains a sequence of directory paths that we're going to want to check on. And in our sequence, we're going to have a dot for the current directory, a dot dot for the parent directory, and then we can combine two dot dots to get the parent's parent directory. And these will be the ones that in our case we're going to search through. We're going to make paths a static variable. This way, this consistent thing that we're going to use is visible in all the functions in the class. With a sequence paths, we can use it in a for each loop. Here's one of the main functions. If we give a simple file name, we want to get a path to that file name to one of possibly several directories that it may be in. And since we've said that this paths variable will be a sequence, we can use a for each loop. It is a sequence of strings, so each individual element, which we will call dir when we pull one out, will be a string. And the basic thing is to take that directory and the simple file name and combine them to get the correct file path. And then we use, again, this function file.exists to see if this file path string really corresponds to a file in our file system. If so, we're done, we found one, and we return it. It's also possible that you go through the whole sequence in this for each loop and you never find a place where this is true, in which case you complete the whole for each loop and end up beyond it. And in that case, we indicate that we did not find a correct path by returning null, used to mean no object. And here are some other things in the same FIO class. An elaboration of getPath is, instead of returning the path to the file, we can directly open a stream reader. We have a function openReader, which takes the file path. Then we use getPath, and then we get our file path back from the getPath function. It's possible that the path wasn't found and file path could come back null, in which case we continue and also return null. But otherwise, we really did find an existing path at file path, and we open a stream reader from that file. Our getPath returned the path string right to the file. We have some places where we just want to know what directory it was in. A slight variation in the code would give us getLocation, which is the directory location of this file name. Then we have a use for that. You may want to write a file to the same directory from which you read a file. So for instance, you could use getLocation to identify a file location, and then we have this just convenience method that if you give it a simple file name that you want to write to, and you want to put it in that same directory location, then the open writer returns us a stream writer, which we get opening the file at this directory with this file name in the directory. The entire class is a project here. It's a library project, and I want to illustrate the use of this library project in FIO usage. Note that in this FIO usage project, I have the source code that I'm going to compile and run. Also, there is a sample.txt in the same directory here. So this is 2 directories up from the execution directory. And let's try and execute it. Let's see what happens. So it says that the directory where we would find sample.txt is ... / 2 directories up from the execution directory, which is exactly correct. The path all the way to the file sample.txt is go up 2 directories, and the file is in that project directory. Then I actually open the file and print it out, and that's the exciting text. And then let's look and we'll see what tests it's passing. Then the program is set up to use the directory of sample.txt to write the output to, and so the output goes in the same directory, and we can look at the code now. So sample here is this simple name sample.txt, which is the name of a file in the project directory. So the getLocation just returned a reference to the directory, that was the ... /... And then if we get a path all the way to the file, that was the second one we returned that ended with sample.txt. Then we illustrated the use of the shorthand open reader with the same name sample.txt. So this is now a reader for the sample.txt file. We check that it is really a reader, not null. And if so, I just wrote the contents of the file. So I read reader 1 all the way to the end, and that string is then written to the screen where we saw it. And that's where we got that the first test was passed. Well, this is another one that I guess I didn't mention in the text. Not only can you open a writer that's in a particular directory, you can open a reader. And here we have the directory where the sample file and the sample file name itself, and it puts those together and opens a reader for us. And we note that it's not null. It's going to be the same file. I don't bother to print it again. We just note that we found it. The second test was passed. Then we have the last idea that I mentioned. If I want to put an output file in the same directory as where I had the sample file, I could get its location and then say put that with the output file name, output.txt, and open a writer to it. Then we actually wrote to the file. I can check that in a moment, and closed it. And since we found it, we passed that test. And this shows the actual path where we put the output. Let's just check now that we actually created that file. If I open the FIO usage containing folder, we see output.txt. I'm going to look at that in Notepad. That's because I'm on Windows here. And the file is in the same directory as sample.txt. That was the text that I was writing to this file. Remember, even though that this output.txt file ended up in the project directory, since it was not explicitly added to the project, you didn't see it in the solution pad. We had to go to the file system to see that it was there. Now, we ran this in monodevelop, where the current directory was 2 directories below the file to be read. But if we went through and opened a terminal and compiled it right there in the same directory, in the project directory, this would still work because one of the places we checked was the current directory. We will be using this FIO class in the future. You're encouraged to make your own library project with the same name as mine in your work solution, or whatever you call your solution. And you will need to copy in just the fio.cs file. To create the library project, it's just like creating the UI library project, only this time it's FIO, as was described in the library projects in Monitor Develop. You can go back and check that.